Hello dear followers of Academy, you're warm welcome again into this session. Here we are going to deal with division law of exponents. For you to understand well the division law of exponents, first of all you have to know these cases. Case 1, when you have a raised to m divided by a raised to n, this is equal to, as it is division and the bases are the same AA, we take a single base, then we subtract the exponent. Now we take the exponent in a numerator, you subtract with an exponent from a denominator. This way. This will only be true if A is not equal to 0. As when it is equal to 0, it can be undefined. Again, case 2. If you have A raised to n divided by B raised to n, this will be equal to. In this, you have different bases, but with the same exponents. So, you take a number in a numerator divided by a number in a denominator, then you express the two raised under the same exponent as it is. Now, a raised to n divided by b raised to exponent n will be equal to a over b raised to exponent n. But this will be true only if b, the number in a denominator, is not equal to 0. As when it is 0, this equation can be undefined. After these two cases, now we are going to see various examples concerning with the division law of exponents. Examples. Example 1 states that simplify each of the following expressions. A, 3 raised to 20 divided by 3 raised to 12. Let's see the solution. A, 3 raised to 20 divided by 3 raised to 12. This will be equal to, as here we have the same base, we take a single base, and it is division, we subtract the exponent. Now we take an exponent in the numerator, we subtract with an exponent in a denominator, which is 20 minus 12. So the answer here will be 3 raised to 8. That is B. In B, we are having A raised to 28 divided by A raised to 17. This will be equal to, as we have that same base, we take a single base, which is A. As it is division, we subtract the exponents. Now, we take the exponent in numerator, we subtract with the exponent in a denominator, which is 28 minus 17. 28 minus 17 this way. Now the answer is going to be A raised to 11. Let us see part C. In part C, we are given 0.47 raised to 10 over 0.47 raised to exponent 6. Here the same, we have that same base, we take a single base, 0.47, then it is raised to 10 minus 6. Now the answer is going to be 0.47 raised to 4, which is 10 minus 6. The last one, part D. In D, we are given 2 divided by 5 raised to 6 over 2 divided by 5 raised to 4. As here we have the same base, we take a single base, which is 2 divided by 5. Then we raise to 6 minus 4. as it is division, we take a single base and you subtract the exponent. Now the answer here is going to be 2 over 5 raised to exponent 2, which is 6 minus 4. This is the answer. Now we are through for the first example. After that, let's go to a second example. This is a second example. It states that write each of the following expressions in the form of bracket, open bracket x divided by y, closing bracket raised to n. A. 13 square divided by 9 square. Now, solution. Let's start with the A. 13 square divided by 9 square. This will be equal to, we are required to express it in form of x divided by y raised to exponent n. Now, it means that we should raise the two given numbers in numerator and denominator, meaning numerator and denominator, under the same exponent. So yeah, is here there is exponent 2, and there's no further way you can simplify together 13 and 9. We may take it as 13 divided by 9 raised to 2. This way. In B, we are given 0.5 divided by 0.3. This raised to 4, the same, and this raised to 4. As both the two are raised to the same exponent, now the answer will be equal to, you take the first one, divide it to the second one, divide it to a numerator, then you put brackets raised to 2, or you express them under the same exponent. This is the answer. But C, in C we are given 16 divided by 3 square. This one will be equal to, 16 is equal to 4 raised to exponent 2 divided by 3 raised to exponent 2. Now the answer will be equal to, as both the two have the same exponent, we take 4 divided by, then we raise to exponent 2. Now the answer will be 4 over 3 raised to exponent 2. This is the answer. Now, this is the solution for example 2. After that, let's go to example 3. Okay, this is example 3. It states that simplify each of the following expressions. A. 625 divided by 5 raised to exponent 4. Up to E. Let's see the solution for this. In A, we are given 625 divided by 5 raised to 4. This one is equal to, the one you could write this way, 625 is equal to 5 times 5 times 5 times 5. 5 4 times, we get 625 divided by 5 raised to 4. This will be equal to 5 raised to 4 divided by 5 raised to 4. This will be equal to, here we have the same base, we take one base, then we subtract the exponents, 4 minus 4. Here it will be equal to 5 raised to 0. But remember, any value raised to 0 is equal to 1. So it's equal to 1. So the answer here is equal to 1. Meaning that 625 divided by 5 raised to 4, the answer is equal to 1. Let's see part B, which is 2 raised to 70,000 divided by 2 raised to 6,999. Let's see the solution for part B here. In part B we have 2 raised to 70,000 this way divided by 2 raised to 6,998. This will be equal to, as the bases are the same, we take a single base, as it is division, we subtract the exponent. 7,000 subtract 6,998. When you subtract 6,998 from 7,000, you get 2. So the answer will be 2 raised to 2, which is equal to 4 to 4. Now the answer for this will be 4. After that, let's see part C. Part C is A raised to 4 divided by bracket 2 a squared plus 4 a squared bracket. This is the same as the one who writes this way. A raised to 4 divided by 2a squared plus 4a squared. It will be equal to, here you have a squared and here a squared. Now we factor out a squared. We're going to have a raised to 4 divided by, we factor out a squared, then here we are having 2 plus 4, meaning that 2a squared divided by a squared we get 2, 4a squared divided by a squared we get 4. Now we are going to have a raised to 4 divided by 2 plus 4 is 6 times a squared. This will be equal to, here is the same as 1 divided by 6 times a raised to 4 over a raised to 2. This is equal to 1 over 6 times a 4 minus 2. The same base, we subtract exponents. We take it one base, we subtract exponents. Now it will be 1 divided by 6 times a raised to 2. A raised to 2 times 1 is equal to a squared over 6. Now this will be the answer for part C. After that, let us see part D. In D, we are given a plus b square over a square minus b square. This will be equal to a plus b times a plus b, because it is a plus b square, so it is 2 times. That's why I have multiplied it this way. Divided by a square minus b square. This is a difference of 2 squares, where we find in which we take the sum of the 2 values times the difference of the 2 given values. Is the law of difference of 2 squares, that if you have x squared minus y squared, the answer, you take the 2 values concerned, the 2 numbers without these squares, by summing up their sum times their difference this way. Now a square minus b square is equal to a plus b times a minus b. In this, a plus b and a plus b cancel out, they are the same. The answer here, we are left with the a plus b divided by a minus b. So this is the final answer. A plus b over a minus b. After that, let us see the solution for the last part, which is k raised to 3 times m raised to 4 times n raised to 6 divided by k times m raised to 2 times n raised to 3. This will be equal to k and k divided by k raised to 3 divided by k raised to 1. We take k 3 minus 1. The same base we take a single base, we subtract the exponent. Times we take a single m, we subtract the exponent. 4, this 4 minus 2. N, we take a single base, we subtract exponent. 6c minus 3. The final answer here will be k raised to 2 times m raised to 2 times n raised to 3. 6 minus 3. This is the answer. Now we are through with the third example.